Good morning, Matrix. Today's lesson we're going to be looking at intersecting circles, and this can mean that you have to sometimes find the coordinates at which the circles intersect, but more often than not, you're working out whether the circles intersect each other twice, once, or no times. And I'm going to do some theory with you now, and then I'm going to do number E from exercise 7.3 as an example. Although you have the memo for that already, but in yesterday's lesson you only had to do up until D. And just a reminder, if you have any issues with any of those, please send me a message so that I can help you. I'll send a voice note if necessary, even make a video if necessary. But I really just want to make sure that none of you slip along the wayside in this online period. Alright, so intersecting circles. If you want to follow in your textbook, we're on page 293, middle of page 293. Okay, so as you can see from these diagrams on page 293, we have different ways that circles can intersect. Okay, so firstly, in this first figure, we can see that the circles are intersecting at two different points. In figure 2, they're only intersecting at one point. In figure 3, they're touching at one point as well, except the smaller circle is inside the bigger circle, as opposed to outside it like in figure 2. And lastly, in figure 4, the circles do not intersect each other at all. Alright, so what we do in terms of how to work these out, they normally give you information without a diagram. So you've got to use the algebraic information and work it out algebraically to see whether they intersect or not. So what we normally do is if there's a bigger circle and a smaller circle, we let the radius of the bigger circle equal capital R, and the radius of the smaller circle equal little r. If both of the circles are the same size, then you can still use capital R and little r. It's really just to differentiate the radii between the two different circles so that you don't get confused as to which radius belongs to which circle. All right, so the basic concept here is that mn, the distance of mn in this circle, if the distance from m to n is smaller than the big radius plus the little radius, then it means that the circles intersect twice. Okay, in other words, there's an overlap. And that should make sense to you because there's an overlap here where the big radius and the small radius are part of the same line. Okay, but if you look at figure 2, the circles will touch externally at one point only if mn, the distance from m to n, is equal to the big radius plus the small radius. Okay, because here you can see the radii don't overlap at all, and so if we add the big radius to the little radius, we get the same as the distance from m to n. Okay, bearing in mind that in these examples, the center of the large circle is m and the center of the smaller circle is n. Alright, then in figure 3, the circles will touch internally. In other words, one circle is inside the other circle if the distance of mn is equal to the big radius minus the small radius. Okay, so the big radius is this line that I'm pointing at now. The small radius is this line. And so if we subtract the small radius from the big radius, we then get the distance mn. And then in figure 4, the circles will not touch at all if the distance from m to n is greater than the big radius plus the little radius. Okay, and then this little distance here between the two circles accounts for the amount that mn would be bigger than the sum of the two radii. I'm now going to do exercise 7.3e as an example with you. Okay, so question E says, a circle, it's at the top of page 293. A circle with center M, -5 and 2, which is labeled, touches the y-axis at E and passes through point F. Question 1, write down the coordinates of E and F. Okay, so it should make sense to you that because there's a right angle here, and because this line is touching the point at which the circle touches the y-axis, it means that this is a horizontal line. Okay, it's parallel to the x-axis. And this line, because it's at 90 degrees, is parallel to the y-axis. All right, so that means then that we know that at E, the x value is 0, but the y value is positive 2. And then for point F, we know that the x value at this point is negative 5. So we have negative 5. And then in order to work out the y value, this is a radius, okay, because it goes from the center of the circle to point E, and it's at x equals negative 5, which means the radius is 5 units, okay, which means that this distance is also 5 units. So because this value here is only 2 units above the y-axis, that means that the bottom over here must be negative 3 units, or 3 units, because we're talking about distance. Okay, but then that means that the y value at F is negative 3. Okay, so it's helpful to put these points onto your diagram in case you need them in further questions. Question 2, determine the equation of the circle. So we know already that the radius is 5, and we've got the center. Okay, so then that means our equation is x plus 5 all squared plus y minus 2 all squared is equal to 25. Question 3, determine whether the point negative 3 and 6 lies inside or outside the circle. Okay, so negative 3 and 6, if we had to estimate where that is, negative 3 and 6 would maybe be somewhere here. Okay, we don't know if it's there or if it's outside the circle, etc. We can't estimate it, but just for argument's sake, we're now going to work out the distance to that point, which is negative 3 and 6. Okay, and effectively, we know that the distance of the radius is 5. So if we work out the distance between those 2 points, and the distance is greater than 5, then it means the point lies outside the circle. But if it's less than 5, then it lies inside the circle. Okay, so let's call this point N. All right, so that means the distance of line MN is equal to the square root of the difference of their x values. So minus 5 minus negative 3 becomes minus 5 plus 3, all squared. And the difference in their y values will be 2 minus 6, also all squared. So minus 5 plus 3 is minus 2. Minus 2 squared is 4. And 2 minus 6 is negative 4. Negative 4 squared is 16. So we have the square root of 20. Okay, so here it's helpful for you to just work out what the exact decimal is. So the decimal is 4,47. Okay, and 4,47 is less than the radius. Okay, so therefore the point negative 3 and 6 lies inside the circle. Question 4. If a circle is drawn through points M, E, and F, determine its equation. Okay, so it's useful to draw a rough circle around those points to get some kind of an idea what you're working with. So I'm going to pause and draw the circle so I don't embarrass myself when it's a rubbish circle. Alright, I've drawn better circles, but that'll do. Don't laugh. I can hear some of you laughing. Alright, so we need to determine the equation of the circle. So the first thing to understand is that FE must be a diameter because it is subtending an angle of 90 degrees on the circumference. Okay, which means that the midpoint of this line will be the center of the circle. Okay, so let's call that point O. and we're now going to work out its coordinates. Okay, so just using midpoint. All right, so the midpoint of FE means that the point O is equal to the sum of the two x values, so minus 5 plus 0 divided by 2, and then the sum of the two y values, so minus 3 plus 2, also divided by 2, and then that simplifies to minus 5 over 2, or minus 2.5, and minus a half. Okay, so that's the center of the circle of which we're looking for the equation. Right, so far, our equation looks like this. X plus 5 over 2, all squared, plus y plus a half, all squared, is equal to r squared. And now we just have to solve for r squared. Okay, there's several different ways you can work out the radius. You can either use distance formula from f to e and divide by 2, or you can work out from this point to that point, because we've already worked out that the center is minus 5 over 2 and minus a half. So I think the easiest way, though, is to substitute one of these three coordinates, either E, M, or F. Okay, so I'm going to choose point E. So we're going to substitute point E, which is 0 and 2, into our equation. Okay, so the x value is 0, so we have 0 plus 5 over 2 all squared, plus the y value, which is 2, plus a half all squared, and that'll give us r squared. All right, so we can put that onto the calculator, and we get r squared equals 25 over 2. And then finally, we just plug that back into the equation. So x plus 5 over 2 all squared plus y plus a half all squared equals 25 over 2. All right, so your work for the rest of the lesson is to do exercise 7.4 on the bottom of page 293. You can do all of it. I'm going to do A1 with you just as an extra example in terms of intersecting circles. All right, so they've given us, they say show all workings to determine if the following circles intersect in two distinct points, touch internally or externally in one point, only or do not intersect at all. All right, so they've given us x squared plus 6x plus y squared minus 2y equals 46 as the first circle, and then x minus 5 all squared plus y minus 1 all squared is equal to 4 as the second circle. So at this point, you actually don't know which is the bigger circle. So we're just going to work out their centers and their radii length to see which is the bigger one, if there is a bigger one. And then from there, we calculate the lengths of the radiuses, compare them to each other, as well as the distance of the centers of the circle. Okay, so we're going to start with circle 1, okay, which is the first one they've given us. And we have to complete the square in order to find the center. So if you remember from the previous lesson, x squared plus 6x, then I'm leaving a space. Then I've got plus y squared minus 2y, I'm leaving a space, and the 46 on the right-hand side. Okay, so now we're inserting that third term for both of those expressions. So for the x expression, half of x, the coefficient of x is 3, then 3 squared is 9, so we're adding 9 here, and we're adding 9 on the right-hand side. And then for the y expression, half of 2 is 1, and 1 squared is 1, so we're adding 1 onto both sides. All right, we can now factorize on the left-hand side, so we get x plus 3 all squared plus y minus 1 all squared, and that's equal to 56 on the right-hand side. Okay, so that means that the center is negative 3 and positive 1, and the radius is equal to root 56. And to get an idea of how long root 56 is, you can put 56 into the root 56 into the calculator to get 7,48. All right. Now we can say then that on circle 2, which they've already factorized for us, so we don't need to complete the square, we can go straight to saying that the center of circle 2 is 5 and 1, and the radius of circle 2 is 2 units, okay, the square root of 4. So when you do have a bigger circle and a smaller circle, it's good to get into the habit then of using M for Mike as your center of the big circle, and then using N for November as the center of the smaller circle, and then your capital R and little r respectively. Okay, so that means that M is -3 and 1, with the radius equal to root 56, and N is 5 and 1, with the radius little r of 2. Okay, the last thing we work out before we compare the radii is the distance of Mn. We need the distance from the center of the big circle to the center of the small circle. So that's going to be using the distance formula. So the difference in the x values, so -3 minus 5, all squared, plus the difference in the y values, which is 1 minus 1, all squared. And we can simplify this to -3 minus 5 is -8, and that squared is 64. And so that means the distance of Mn is 8 units, okay? Because the 1 minus 1 is 0 squared, which is 0. All right, so we know the distance of Mn, and we know the distance of the 2 radii. Okay, so what we do now is we are going to add the 2 radii. But before we do that, let's just remind ourselves of the conditions. Okay, so the first thing you do is you add the 2 radii together. All right, if that answer is greater than the distance between the 2 centers, then they intersect in 2 different points. If it's equal to the distance of the 2 centers, then it means they touch externally at 1 point. If it is greater than r plus r, the distance Mn, then it means that they do not intersect at all. All right, so we know that the distance of Mn is 8, so we're now going to work out the sum of the 2 radii. So that's root 56 plus 2, and I'm just doing that on my calculator as well. So root 56 plus 2 gives us 9,48. All right, and that means therefore that Mn is less than r plus r. Okay, and because Mn is less than r plus r, it means that the 2 circles intersect in 2 distinct places. All right, so you need to please carry on with the rest of A from 2 to 5, and then B 1 and 2. Thank you all, and have a wonderful day.